Bismillahirrahmanirrahim. Hello everyone. This is Engineer Irfan Ali and I am the course instructor for this design course. This is a brief demonstration for the overall course that what we will be doing in this design course, right? So you already know about the course contents of the this course. The first one is the basics of the ETABS and SAFE, but we will make this as a module 2. We will study about the introduction of the structure systems and the types of the slab system and introduction to the different design codes. Because when we study these type of the slab system and the structure system, so we can discuss this in the basics of the ETABS and SAFE as well. So I have included some of the course contents for the few of the modules, so that many of the students they were asking about the lectures, how the lectures will be, so they will have an idea that how the lectures will be and how we are gonna do this one by one. So this is module 1. In module 1 we will be studying in the structure systems. We will be studying about the bearing wall system. This is just for the introduction. And building frame system, moment resisting frame system, dual system, and what are their references in the code. And then type of the slab systems, which is the beam slab system, which is very common. And then flat slab system, flat plate system, and joist system. And at the last we will be studying the design codes. So I have included the first one, this bearing wall system, just for the demonstration, and we will study in the overall structure systems in our module 1. So actually the bearing wall system is the system in which the loads are primarily resisted by the walls. There are no columns and no beams, so it can be confined, unconfined, right? So you can see this is the unconfined masonry, brick masonry. This is the unconfined concrete block masonries, and these are the confined masonries which consist of the columns and the bend beams, right? So what does the code says about these structural systems in the Building Code of Pakistan 2007, table 5.13? It says about the general view or the structural parameters for the different structural systems. That, for example, the bearing wall system, it consists of different systems, and if we check the masonry, that is shear walls and masonry, and it has its own R wheel use, which is the response modification factor, and the amplification factor is overstrength factor, and the other one is the height limitation for the seismic zone 3 and 4. There is no limitation on for the seismic zone 2B, 2A, or 1, right? So we will discuss these structural systems one by one with the code reference, right? And the next would be the module 2, which is about the basics of the ETABS and SAFE, and we will go through the interface of the two softwares, which is the SAFE and ETABS, and then we will use the common command, which is basically used in the design of the buildings, and at the last we will be finding out the common modeling mistakes which normally students do, right? So in the E-tab, we will talk about the interface, about what are the different tabs and how we are going to use it. What on the left side, for example, if I talk about the draw, so you can click on the draw beam column brace objects from here as well. So you can draw your beam, right? And you can also use this command from the quick command icons, and this is, for example, the same one which we have selected from the drop down menu. So we will discuss this in detail in our module 2. The next is the module 3, which is about the modeling of the proposed 10-story building, and we will discuss three methods. The first one method is the direct importation of the grid lines or columns from the CAD file if you have very irregular structure that you cannot draw on the grid lines. The second method is the use quick draw templates of the ETABS, and the third method would be the use of the grid lines in ETABS. We will be studying these three methods, but we will be completing our 10-story building using one of these methods, right? So let me give you a quick review on the first method. Let me undo this. that I have imported the columns from the CAD file. So we will be studying how to import these and how you can draw the columns within one click. So let me show you. You can see on the right side, this is 3D view. So if I right click on the 8 columns, so you can see that all the columns has been modeled in the 10 stories. So how we do that? So you can easily disappear the architecture plans which I have imported from the kit, and then you can draw your beams and slab plans from joint to joint. Let me off the all stories, and you can draw your beams and you can draw your slab as well, right? So we will be discussing different commands with the different modules, so you can learn the design as well as the ETAB different commands. The next is module 4, in which we will study about the defining material properties for the concrete, that what does the ACI code says about the limitation of the material properties and about the steel rebars. And then we will be discussing the section properties, and we'll be defining the section properties for the columns, beams, walls, slabs, and the at the last we will be talking about the stiffness modifiers that will be used in the design. So I have included a slide from the lecture, that is the walls. For the wall section, we will be discussing the minimum thickness for as per the ACI 318-14 table 9.3.1.1, that the sorry, this is the 11.3. So the table 11.3.1.1, the minimum wall thickness should be according to this table. So we will be calculating the wall thickness for our model, for our walls, for our lift walls, shear walls, and retaining walls according to this table. And this is the mass source for the module 5. Let me go to the E tab and let me show you the tabs where we can define the material properties. We'll go to the define material properties. Here we will define our material properties. For example, this is the 4000 psi, this is for the concrete, and we will talk about the models of elasticity, how we can calculate this. For example, if it is not included in the E tab, for example, if I want to calculate it from the 1500 psi for the 12,000 psi, so how we can calculate the models of elasticity for this type of the concrete. And the next is the steel rebars, that what is the difference between rebar and what's the difference between the steel. So we will be talking about that. And then we will go to the define different section properties from the ETAB, for the ETAB for the columns, beams, and the walls and slabs using these tables. This is just for the columns. We will also take the minimum thickness for the columns, beams, and slabs. The next one was the module 5, that was the defining the load patterns, super dead loads, and etc. for the mass source. So I have included a slide from the lectures, that is the mass source. The base shear is actually defined in UBC 97 section 5.30.2, that it is calculated from this equation, and in this equation the different parameters will be defined, but the main thing is this W, which is the seismic weight. So in ETAB you have to define the mass source in order to find the weight of the structure. So from where the weight will come, what does the code says. So we will be discussing these parameters in our lecture. Let me go to the E tab and let me show you. Go to the define, click on the mass source and click on the modify. So we will be talking about this tab, so how which loads will be included in the mass source and how the ETABS or the software is calculating the mass source, and that will be used in the calculation of the base shear. The next one is the assignment of the loads to structure members and the selection of desired codes, and that will be discussion on the results. So let me go to this. This is a sample model. So we'll be talking about the design course. You can select from the go to the design tab, and then we will go to the concrete frame design, and here we will select the desired code. If you want to select ACI 31814 or European code, Indian code, Hong Kong code, you can select that and you can design your structure as per your country. The next would be discussion on the results. For example, if I talk about the bending moments, so you have to go to the display frames and you can click on the bending moment 33, and you can see the bending moments in the beams and in the columns. If you right click on this, so you can check the exact values, that is the equivalent loads share on this beam and the moment acting on this beam, and you can check for the different load combos, as well as you can check the major axis for the minor axis, and you can also check for the axial. So we'll be talking about these results. If you want to check the stresses in the shade, you can click on this, and if you want to check the normal forces, so you can check the normal forces F2 to F11 for the different load combos. For the this is the stresses, so these are the values S11, and this will be S22 in the other direction. Right, so you can check the top face, the bottom face, maximum, minimum values. You can check accordingly for your research or for your case studies as well. The next is the calculation of the lateral drift, that is known as the lateral deflections, and the torsion error will be checked using a design sheets. So let me show you the design sheets that we will be using for the torsion irregularities, and we will be using this sheet that we will be importing the values from the ETAB, and it will tell us that the structure is regular or irregular, right? And this is for the X. Similarly, it is for the Y direction. You can see that it has shown irregular for different values that we will be discussing in our course. The next would be the structural design of the columns and beams as per ACI 31814. If I go to this sample one, and let me show this display formation, and you can see that I have shown the longitudinal reinforcement in the beams and columns. So we'll be discussing about these values. If you right click on this, so you can see that it has been designed for the combo 2. And if I go to the summary, it will give me a report, and we will be discussing this report, that what is the percentage value for this is 1%, and what is this, for example, the EC value is used, this one FC prime is used is 4000, and we will be talking about the type of this sway special, how we can make it the sway intermediate, non-sway, etc. What does it mean? So we'll be talking about that. If I go to the interaction, and you can see that there is the interaction diagram for this column, and you can check the demand to capacity ratio for these columns. If I go to the against combo 2, it says the demand to capacity ratio is 0.176. It means it has utilized 17% of its capacity, so it has 83% capacity remaining. Similarly, if I click on the beam, you can see it is open the tab. You can go to the summary, and you can check the different parameters and the material properties, design parameters, and then there is reinforcement. And we were talking about the top reinforcement, bottom reinforcement, torsion reinforcement, and shear reinforcement. And we will be talking about, and we will be designing our beam according to ACI 31814. The next one is the structural design of the slabs and SAFE using ETABS results. We'll be exporting our slab from the ETAB to SAFE, and let me open a sample. For example, this will be a sample of the slab. So if I click on the display, click on the show slab design, so it will give me finite element base, so it will give me reinforcements, right? So this is the top reinforcement, that would be the bottom reinforcement. So how we can give the reinforcement, for example, if I want to give number 4 bar at the rate 6 inches, what would be the results? right? So we'll be talking about that, how much reinforcement is here. For example, there is 0.18 inch square per foot, so how we can calculate the spacing using different number of bars. So we'll be talking about that. The next would be the structure design of the lift walls, shear walls, and retaining walls as per the code. So if I go to this model, if I click on the shear wall display information, let me show the longitudinal reinforcement of the walls. So if I right click, so there is a report on the shear wall design. So there are different pair details, what is pair, material properties, design codes, and this is the reinforcement required, which is 8.6 inch square. This is for the flexure, this is the shear, which is the 0.63 inch square per foot. So how we can use this information in order to design our shear wall, and how we can use this in the, or tell our draftsman to draw the shear wall drawings, right? So we will design our shear walls, default shear walls, according to, there are different methods in the shear wall. For example, if I go to the actually this is, the analysis has been run, so this is non-applicable. So there are three methods, which is the uniform reinforcement, CNT method, and general reinforcement. In the shear wall and lift wall, we will be briefly discussing these methods as well. The next 11 module is the modeling and design of the raft in SAFE, that we will be exporting the results from the ETAB, and then we'll be importing the raft with the results in the SAFE. If I go to the sample one, this is actually the raft. So this is showing me the punching ratio. So how we can calculate or design for the punching design, and then if the punching ratio is greater than 1, so how we can design the integral beam for the raft. Let me show the reinforcement in the raft. Go to the show slab design and go to the finite, show me the bottom reinforcement in the direction 1, which is the x direction, and this is the direction 2, which is the y direction. So these are the reinforcement. If I go to the none, so these are the contours, which says the reinforcement is 0.27 inch square per foot in the two direction of the bottom. Let me check the top. At the top is, it is 0.35 inch square per foot. So how we can check for the different number of bars at different spacing, and how we can finalize our raft design, we will be discussing that, and we then at the last we will be drafting our raft. The next would be the serviceability checks, that is the long-term and short-term deflections, and then at the last we will be doing the drafting, right? So we will be checking the long-term and short-term deflection in the SAFE, and what load combinations or load patterns will be used in the calculation of the long-term and short-term deflections. If I go to the define load cases, and let us add a new case, right? So there is a tab, you can see that there is a linear, non-linear uplift, non-linear crack. This is the short term and this is the long term, right? So what type of load will be used in these, and what will be the factors for these load patterns, right? So we will be discussing that, and we will be checking the limitations that is being implemented by the code. For example, if the limitation is 0.5 inch square, 0.5 inches deflection, so the deflection should not be greater than 0.5 inches. So what will be the next step if the deflection is greater than limitation? So we will be discussing that as well. So this was the overall view of the review of this course, that what will be we will be doing or studying in this design course, right? So I hope many of the students have cleared their doubts. So if you are interested, you can go and scan this barcode, so you will get the instruction and registration page. Submit your fee, do your registration, and at the end you will when you submit the Google form, you will get a link to the WhatsApp group. That is the only for those students who have submitted the fee, they will join the WhatsApp group, right? and then we will be sharing the Google Meet link in that group, so you can join me while we will be doing this course. So remember that please do the registration Google form, including your father name and email. Uh, the in the registration form, I will also generate a new form in which the students will give their email addresses, so I can add up in the Google Classroom or the Google Meet, so they can join me and we can go on with this course. I hope this is clear. See you on the upcoming Monday to start our course officially.